Hey everybody, it's now day 2 of lesson 3.1, and this time we're going to be looking at um, some more descriptions, really, of our linear relationships with our Barbie. So here we go with how safe is our Barbie. So how can we sure that the bungee cord we make Barbie will keep her safe? Should you be worried if you use the wrong units, choose the wrong axis, or measured incorrectly? Okay, well below here is the data for one group's Barbie bungee. Okay. We have the number of rubber bands, 1 through 7, just like we did last time. And over here we've got the distance traveled, but this time they measured in inches. So we're going to go to Statlet.com and we're going to create our scatter plot. So here is our scatter plot. We've left some room over here on the right side. You notice that our x-axis goes all the way to 14, 15, 16, somewhere around there. And let's find the correlation. Well, looking at Statlet, we'll notice that over here there is this button that says Calculate Correlation. And if I push that button right over there, Calculate Correlation, I get R equals 0.992. Now right now, we're not going to worry about how you would actually calculate that using equations. We're just going to say that, well, yes, you can always find the value of R using your Statlet or using your calculator. So what does that number mean? 0.992. Well, that number 0.992 can tell me that the relationship here that we're looking at is actually a very strong relationship. That number, R, the absolute value of 0.992, is very close to the number 1. The values of R are always going to be between -1 and 1. Now, I can tell it's strong because that value is close to, in this case, +1. If R was -0.992, then I would say that it has a negative relationship. So the sign of R tells me, do we have overall a positive relationship or overall a negative relationship? I can tell it's linear because I'm looking at the scatter plot. So very important for you to know, R by itself will not tell you if a relationship is linear. You can calculate R even if the relationship is really non-linear. So be a little bit careful about that. There is no one variable statistic that will tell you everything you need to know about a relationship between two variable data. So, knowing that we have a strong linear relationship, how safe do we feel Barbie will be in her bungee jump if we use this data? And I hope you would respond with something here like, we feel very safe because we have strong correlation. There is a strong correlation between the distance traveled and the number of rubber bands. So that means our linear relationship, whatever the linear relationship is, we think that it's going to have very strong predictive patterns. Let's look at question 4 here. One of the group members snuck in some extra rubber bands to collect more data. Ooh, sneaky group. They added 15 rubber bands and 49 inches to the scatter plot. And how do you think this outlier will affect correlation? Here's that new point up over here in the top left, top right, and the question needs to be, does this point follow the pattern or does it not follow the pattern? And yeah, it does seem to follow the pattern. If I go ahead and I draw myself a line of best fit here, through the old points, it does seem like this new point is following the pattern of the old points. Since that new point follows the pattern, the strength should increase. The strength of that linear relationship is only going to increase. So that means that the value of r should also increase. Let's check. Here I've gone ahead and added that new point, and I'm going to check correlation, and look at that. Correlation is 0.998. So just like we thought, the value of r increased. Now it increased not that much. It didn't increase a large amount because our value of r was already pretty big. So there's not a whole lot to do to increase that. So that brings us to our number 5. One group member accidentally left off a digit. So we're going to add the point 6 rubber bands 6 inches to the scatter plot. Let's see where that point is going to be. 6 rubber bands 6 inches. That new point is going to be right about here. 6 rubber bands 6 inches. And what do we think is going to happen here? Well, this is the opposite thing. This is an outlier in the y direction. The the y coordinate, the distance traveled, is much lower than expected. This new point does not follow the pattern. Therefore, the strength should decrease. The value of r, likewise, should also decrease. Here's our new scatter plot with 6, 6 on the graph right around here. And calculating that correlation, look at that. Our new value of r is 0.838. Just as predicted, our value of r decreased. Now we are at 0.83. Still a pretty strong relationship, just not as strong as it was before. Okay, unfortunately, the group had measured the lowest point on Barbie's head in inches instead of centimeters. So to do this, they had to multiply everything, all of their distance traveled, by 2.54, which would be the conversion factor from inches to centimeters. And we got the new data here. So how do you think these changes are going to affect the correlation? Well, do you have an idea? Let's go ahead and put this into our scatter plot. Take a look at our scatter plot now with the new set of coordinates. That should look kind of familiar. If I put the two graphs side by side here, and I take a look at the pattern of the scatter here, this pattern of scatter here looks pretty much identical to this pattern of scatter here. And this kind of goes along with what we were saying before. If you multiply by a variable, or I'm sorry, by a constant, you're not really changing the structure between well, it didn't change the structure in a dot plot, and it sure as heck not going to change a structure in a scatter plot. And if it doesn't change the pattern in the scatter plot, then you might suspect that the correlation is going to remain the same. Hopefully you suspect that the correlation is going to remain the same. And in fact, when I calculate correlation, I'm going to get that same original correlation, 0.993. So the correlation does not change because the points do not move away from each other. Incidentally, we've gone and kind of through the back door, started talking about this quantity called correlation. Correlation, as we have here, correlation is the same thing as R. So you may have caught me in class telling you not to use the word correlation because correlation means something specific in statistics. And this is what correlation means in statistics. Correlation refers to the, it's the numerical value which evaluates the strength in a scatter plot. So don't use correlation unless you are talking about the strength of a scatter plot. And that brings us to our describing relationships here. So interpret R. R, you can interpret direction, positive or negative slope. And you can talk about form, which should always be linear in AP Stats. And you could also talk about strength. Now we have some guidelines here. If the absolute value of R is less than 0.6, you would say that you have a weak relationship. If your absolute value of R is somewhere between 0.6 and 0.8, you would say you have a moderate relationship. And anytime you have the absolute value of R greater than 0.8, you have a strong relationship. So more about correlation. R does not have units. It's a unitless number. If you switch the axes, so if you if you make a mistake and you say that your explanatory variable was actually your response variable and vice versa, then that's not going to change. That's not going to have an effect on R. And that's because you're not changing the distances between the points in your scatter plot. And finally, correlation R is non-resistant. If you have outliers in the same pattern, that's going to strengthen R. But if you have outliers out of pattern, that's going to weaken R, and usually very dramatically. And the other thing here is correlation does not equal causation. And what that means is that if you have a value of R, absolute value of R, greater than 0.8, that doesn't indicate a cause and effect relationship. It just means that the scatter plot shows a very strong linear pattern. Pattern has nothing to do with causation. And if we think we have all of that, we can go to check your understanding here. Most people love chocolate for its great taste, but does it make you smarter? A scatter plot like this one recently appeared in the New England Journal of Medicine. The explanatory variable is chocolate consumption per person for a sample of countries. The response variable is the number of Nobel Prizes per 10 million residents of that country. So let's interpret the value of R equals 0.791. Since R is close to 0.8, we would probably say that there is a moderate to strong positive linear relationship between chocolate consumption and Nobel Prize winners. Remember that the number 0.791 can't really tell us a linear relationship, but we can tell the linear relationship based on the scatter plot over here. So if people in the US started to eat more chocolate, can we expect more Nobel Prize winners to be awarded in the US? Explain. Hopefully you already know that that's a no. So no, correlation in this case does not mean that one variable, in any case I should say, correlation does not mean that a change in one variable is going to cause a change in the other. Most likely there is something else that's impacting both variables, and you can take a good guess that that's probably the economy of the countries, and perhaps maybe the educational system of each country. Okay, So what effect does Switzerland have on this correlation? Let's locate Switzerland. Where is that? Switzerland is right over here. And Switzerland kind of follows the pattern here. If we used a highlighter to outline the pattern, it would probably look something like this green line here. And so Switzerland is following the linear pattern. So since Switzerland follows that linear pattern, it will strengthen the correlation. And that's our lesson for today. No real calculations that you needed to do yet. And that's kind of keeping in what we do, or keeping in pattern, just like today's lesson, keeping in pattern with what we do here in AP Stats with correlation. We'll definitely look at ways of calculating that at some point, just not right now. So enjoy, have a good day, and we'll see you next time here for more AP Stats.